Hello and welcome to section 2.4, the chain rule. And so to start out with this first example, I know it's example 2, but it's actually the first example that we're going to cover. We need to be able to kind of take functions apart, because when we do the chain rule, we're assuming that there's a function inside of another function. And so that's what we're going to take the derivative of. And so first thing we need to do is practice taking apart the function so that we can take the derivative of the easier function. So the first thing is I need to find out what my inner function is, and in this case my inner function is going to be u equals x plus 1. And then my f of u function, my new function, will be y equals 1 over u. And so you can see that I'm replacing x plus 1 with u, and so this is the function I take the derivative of, and we'll go on with what the chain rule is in just a minute. I'm not going to simplify this. I'm not going to do it right now. And so then this next one, we have to figure out what our inner function is. And whenever you have a trig function, the majority of the time the inner function is the extra stuff that's not just an x in there, and that's how you're going to know it's a chain rule. So my inner function is going to be u is 2x, and when I rewrite this as y equals f of u, it's going to be y equals sine of u. And so we'll talk about it. So this right here, when we start, we'll take the derivative of this function, and then once we take the derivative of this function, we'll multiply by the derivative of this function over here, and that's pretty much the chain rule. So then the next one here, my inner function, you'll notice I'm taking the square root of this whole function here, and so when I do that, this thing becomes my inner function, and so that's the function I'm going to deal with, which is 3x squared minus x plus 1, and then my new function would be the square root of u. And so hopefully when you look at this last column and you have to take the derivative of the last column, this is definitely a lot less scary than trying to take the derivative of what you're looking at over here, hopefully. And so then for my last one, I have to figure out what my inner function is. And this one's a little bit trickier, but a lot of times when you have a trig function squared, and part of the reason why I know this is my inner function is, if you remember our trig rules for differentiation, we do not have a trig rule for tangent squared. We have a differentiation rule for tangent, but we don't have one for tangent squared. So that's where this is going to come about, so that my u is going to be tangent of x, and then my new function will be u squared. And so we can do power rules on most of these guys and take the derivative of them, and then we'll follow the rest of the chain rule. So when we're doing a chain rule, we're looking for inner functions and outer functions, and so this is just practice on writing them that way. So then we get to something that looks like this, and for our next example they say find dy dx, which is basically the derivative of this function. And if you really wanted to, you could multiply this out and say x squared plus 1 times x squared plus 1 times x squared plus 1, and you could do the product rule, the extended product rule on this. You could multiply them all out, but basically you'll get to the same thing, but hopefully the chain rule will help shorten that process. So if I'm going to take the derivative of this, I need to find out what my inner function is, and my inner function is what I'm not cubing, so that's going to be x squared plus 1. And so my new function, my y, is going to be really u cubed. So now I haven't done any calculus yet. I'm just replacing my inner function with u, so I can do this. And so then I'm going to go ahead and take the derivative of my inner function, which means that I get y prime will give me 3u squared, but then I have to multiply, as the chain rule says, I have to multiply by the derivative of that inner function. So I'm going to multiply by the derivative of the inner function, which what is the derivative of 2x squared plus 1, which is just 2x. So now if I replace u with what I said it was at the beginning, then if I replace it with that and do some simplification, I'll have my final answer. So y prime turns into 6x, I just multiplied the 3 and the x together, times this thing squared, x squared plus 1 squared. And I don't have to go any further on my simplification of this. That would be an okay answer for this example. And so you might want to, when you're doing this problem, you might want to say, oh, I'm going to take the derivative of this function right away, and that's du dx, which would give me 2x. And then so then I know that when I'm doing this, I'm going to take the derivative of this function, multiply it by the derivative of the u function. So, and sometimes we write the chain rule like this. We can say, well, we'll talk about that in just a minute. So moving on to the next one, we're same idea. We're looking for an inner function and an outer function. You'll notice that again, my inner function is going to be 3x minus 2x squared. That's going to be my u value, my inner function. If I take the derivative of that function with respect to x, I'm going to get 3 minus 4x. And then I'm going to go ahead and rewrite my function with u in it. So f of x is really u cubed, and hopefully when you see this, that you thinking of taking the derivative of it doesn't seem so scary. And so when I take the derivative of u cubed of my u function, and really it should be in terms of u, I shouldn't be writing it with x over there. It's because I changed it. I'm doing it in terms of u for proper notation, and so I will get 3u squared. And so now I have to take the derivative of u, which I already did, which was the 3 minus the 4x. And so my final answer, when I take the derivative and replace u with my x's, I get 3 times 3x minus 2x squared times 3 minus 4x. And probably what I should have done is to change this, is I probably should have said that I'm going to take 3u squared, there's my derivative of this, and then I have to take the derivative of the u in terms of x, which would give me something that looks like that. And so then replacing the given information in blue down below, that's actually a little bit better, little more proper notation to get us our final answer. And personally, I would not multiply this together. I would just maybe move things around to make it a little simpler, but this is a fine answer for the problem. And so then, moving on to the next example, it says find all the points in the graph of this function for which f prime of x equals 0, and for those that where f prime does not exist. So I'm going to go ahead and say, okay, I'm going to take f of x, and well, I'm going to find my inner function and outer function. And so my inner function in this case, well, let's just write f of x again, because it looks so confusing the way it's written over there, the way it's typed. I have x squared minus 1, and the whole thing is squared. So really I could write this as, if you'd rather, x squared minus 1 to the 2/3 power. That's a little bit better because I'm taking the cube root and I'm squaring it. So now if I want to do it in terms of u, my f of u function would be, well, first of all, we should probably pick out what u is then. So my u function is x squared minus 1, and so my f of u function is now u to the 2/3 power, which isn't as bad. And so remember, if I take the derivative of a u function, I do f prime of u, and so I'll take the derivative of this, which is 2/3 u, and then I reduce it by 1, so I get a negative 1/3, and then don't forget that I have to take the derivative of the u, which gives me this notation. And so what I forgot to do up here is take the derivative of u. I didn't really forget to do it, I just wanted to wait till I got to that point. And so I ended up with my 2x, and so now I can replace everything. I'll replace all my u's with x's, and so f prime of x is 2/3 of x squared minus 1 to the negative 1/3 times 2x. And so, while that notation doesn't look great, but what I can do is I can write this as a fraction, which will kind of make things a little bit better for me. And so if I write this as a fraction, I get f prime of x equals, well, the top becomes 4x when I multiply the 2 and the 2x together, and the denominator will turn into 3 times the cube root of x squared minus 1. So now if I'm asked to find out where this doesn't, where we have horizontal tangents, or where it doesn't exist, we can go ahead and set the numerator equal to 0. That's where we'll get horizontal tangents. We would set this whole thing equal to 0, but remember, solving algebraically, we're going to multiply the bottom times 0. So in order to find where we have horizontal tangents or where the slope is 0, we can just set the top, so 4x equals 0, which means x will equal 0 is where we have horizontal tangents, which is part of the question they were asking. Or where f prime equals 0, and so that's basically that part right there. That's the first part. Where it doesn't exist, this is where f prime of x equals 0 is x equals 0. Where it doesn't exist, well, if you remember where things don't exist, it's usually when the fractions that we get, where the denominator is actually 0. So I can just set the bottom equal to 0, and that will give me where if I set the bottom equal to 0, then that'll give me my does not exist part. So my does not exist will be 3 times the cube root of x squared minus 1 set equal to 0. And with a little bit more simplification, divide by 3. Okay, that's still 0 divided by 3. Cube both sides gets rid of that, so 0 cubed is still 0. So I really have x squared minus 1 equals 0. And I can add 1, so I get x squared equals 1. And square root of 1 is plus or minus 1, and so this is where it doesn't exist. So when you look at the graph, it does something like this. It comes in, sharp point at -1, flattens out, does that, sharp point at +1, and so right here is where I have my horizontal tangent at 0, and then these two guys are positive and -1. So what's happening here is that's some of the things that we're going to be dealing with, is finding horizontal tangents and finding out where it doesn't exist. So moving on to the next one, we want to differentiate this. And the first thing when you look at this, you might ask yourself, do I need to do a quotient rule because I have a fraction? And some people say yes, that's the first thing you're going to want to do. But actually, probably you don't want to do a quotient rule on this, just for the fact that you don't have a t in the top and in the bottom. Since you only have a t in the bottom, I'm going to write it like this, with a -2, with an exponent of -2. And by writing with an exponent of -2, I get rid of the whole idea of the quotient. And it's not even a product rule because the top didn't have a t in it, and with the top not having a t in it, I don't even have to do a product rule. It's just going to be a power rule situation. But again, I need to go through and say, oh, okay, u is 2t minus 3. If I take the derivative of that, which I will eventually need, whoops, it should be with respect to t, then I get 2. And so now my g of u function is really -7 times u to the -2 power. So now I can go ahead and follow my chain rule, which says take the derivative of u and then take the derivative of this function and then multiply it by the derivative of u. So g prime of u would be, well, -2 times -7 is +14. Reducing the power by 1 will get me -3. So I have 14u to the -3, and then I got to multiply it by the derivative of the u value with respect to t, which is 2 in this case. And so when I go back and replace everything with the t value, my g prime of t would be 14 times 2 all over, and I'm just going to move the negative down to the bottom, 2t minus 3 cubed. So the best I can do is 28 over 2t minus 3 cubed. And so that's the derivative that I'm looking for this function. So I'm going to stop right here in this section of chain rule. We'll have a part 2 to complete the rest of the examples.